Okay, so today, so the premise is like, our point here is like we want to get to somewhere where we can start thinking about how do I build a non-trivial application on the web, and how do I scale it up and think about all different levels of complexity that are involved in my application, and how do I do this effectively. And the premise of today's lecture was to kind of get everyone on the same page and say, okay, last time we talked about this stuff related to building front-end components. Today we're going to talk about the web a little bit more generally as this place where you transfer data around. And then from here, we kind of have this base understanding of what the architecture of the web is, and we can talk a little bit more seriously about the kinds of things that you really need to think about when you're making any kind of application. So today is just kind of getting a sense for how do you move data around on the web, what are the protocols to do so, and just touch on what databases are, because this is not, I think, this is not something that people know right away. Okay, so as always, please leave feedback. I think if there's only 4 people, we can kind of go through feedback individually at the end if that's something you're interested in. But in any case, this is the link. Please leave some notes there. It's very helpful. Okay, so the first question that we can ask is, let's say I open up some web page in my browser. So here I have the New York Times, right? I think if this is the first time you kind of think about how websites work, it's not obvious where the data on the web page should come from, right? So first of all, it's obviously not the case that the New York Times is like looking for the data about articles or pictures on your machine, right? I think one idea immediately is like, oh, okay, like you just have the data somewhere, and the website looks it up on your computer. Well, obviously that's not the case, because when have you ever downloaded all of the New York Times data? There's no reason to assume that anyone has done this. So we have to ask, like, okay, where do we actually get this information from, and how do you kind of load it onto this web page? And so, like, you think about this for a minute, and I'm sure by now to you it's pretty obvious. Like, okay, well, it's the same place where you got the New York Times stuff from. It's like somewhere out there, far away, and you kind of threw it over the wire on this thing that we call a network, and you kind of wave your hands, and and then it like renders nicely on your browser, and you're happy, right? So now we want to ask a little bit more specifically, like, okay, well, what happens in all this hand waving stuff? What actually does this hand waving look like, and where do we start waving our hands from? Okay, so this is the problem. Like somewhere far away, someone has a bunch of this New York Times article data, and you say, like, all right, I want the New York Times, and they throw it across the wire, and it looks really nice for you. And then like one immediate thought is like, okay, well, if someone else really far away has all this New York Times data, like, why don't they, like, they can just send us everything, and then like that's what we show on our screen. And so, like, you think about this for a minute, you're like, okay, well, this kind of makes sense, but then you're like, well, this breaks down really quickly, right? And why does it break down really quickly? Well, because this would be kind of a terrible way to do anything on the internet. There's no UI, there's no UI component to this at all. There's no interaction component at all. If you just send someone a bunch of data and you say, okay, like, here's where you want it, it's a bunch of articles or it's a bunch of pictures, you don't have any meta information telling you, like, how should I display these articles? What are the articles I actually care about for today or this year or whatever, right? Because for example, news goes back hundreds and hundreds of years. So you don't want someone to just send you a pile of data, and the first thing that you see is like articles from 1945. You're probably more interested in whatever has happened from 2020 or 2021. And the other thing that you don't get is you don't get any of this information about how you should move between different pieces of data. So like, how does one article relate to another, or something like this? And so if you spun a little bit, you're like, oh, okay, well, obviously all these things are problems that are solved by the internet. So on the internet, like, you have this kind of really nice way that you can, like, send data across the wire, and it shows like a nice web page, and then you click on something, it takes you to another web page. So like, we kind of went like the course's direction, and I would say, oh, okay, like this is not going to work at all. And it's kind of obvious that it's not going to work at all. And instead, we have this nice thing called the internet that allows you to do this. But still, there's this question that remains, is like, okay, like if we know that this is the way we want to do things, which is that instead of just pumping a bunch of data, you want to kind of also send some information about how to lay out the data, what to display, and how to move between different kinds of data. You still need someone to tell you how to be able to do these kinds of things, right? So I don't know how to do that on my browser, because, like, I mean, that's what I'm asking the New York Times for. And this big sink of data that just contains a bunch of information that the New York Times has, like pictures and articles and stuff, doesn't really know that either, because all that is just like a giant pile that we just talked about. So you need someone in the middle, right? You need someone in the middle to help you move between, okay, I want some information, and actually retrieving that information. So this is the idea of a web server, right? The idea of a web server is you just have some intermediary between yourself and a whole bunch of data that helps you transition from getting that data and representing it and moving between it, right? So here's like a very simple idea of how this interaction could work. I could be sitting here and saying, I wonder what the New York Times looks like right now. So again, we're going to do a little bit of hand waving. We're going to say, I ask someone far away. We'll call this the New York Times server. And again, I'm kind of intentionally making it vague how exactly we do this, because we don't really have the time to go into DNS and a whole bunch of other stuff. But we'll dig a little bit into HTTP later. But we say, okay, so out somewhere, we just know that there's someone responsible for giving us the information of what the New York Times looks like, called the New York Times server. So we ask them, what does the New York Times look like right now? The New York Times server says, well, okay, we have some UI or UX engineers that have built us this really nice looking web page. But the problem is that, like, this is what the web page should look like between different visits, but we're not quite sure what the articles that we should put in there are yet. So as you might imagine, it's not really the case that you want to be creating a new UI every time you have a new article that's being published, on some article website, for example. So instead, you kind of create like the shell that's like, okay, well, here's where we're going to put articles in, but you haven't yet concretely made those things until you know what the articles you want to put in there are. And where do we find where the articles that we want to put in are? Well, this comes from this giant data sink of data that the New York Times has. So let's call this the New York Times database. It contains a bunch of articles relevant, to the New York Times, and the server says, okay, well, here I am. Someone just asked me for what our webpage looks like on today. So what is today? March 9th. I should probably go and get articles that are relevant for March 9th. So New York Times reaches out to the database, says, hey, give me some articles for March 9th. Database says, okay, great, I got you. Here are the articles for March 9th. The New York Times server takes those articles again. It says, okay, now I know what to put into the articles that I want to display on this web page that I'm going to give to you. It puts them in there, says, here's the home page, sends it back to me, who made the request. And I'm like, okay, great. Now I have the New York Times that I can read all I want to my delight. Right. So again, we're kind of humanizing this interaction. Obviously, it's a lot more coarse and machiney than this, but if you haven't seen this kind of thing before, I think it's a little bit, it's kind of non-obvious what's going on. And so I hope this makes like, hopefully this made some sense of analogy, whether you've seen this 100 times or just once. And if not, let me know. Okay, so the first question, and I've kind of got into this for a second, but I think it's a little bit useful to think about is, why would we want to distinguish these two things? So remember, like, the server guy is the one that's responsible for saying, hey, okay, this guy wants something. Let me do something and give you back a nice representation that you can see on your browser as a UI or something. And we have this database thing that just contains a bunch of data. And I think a natural question is, why not just combine these two things? So you have both the entity that's responsible for representing some information in a nice way that you can visualize, and the data associated with that visualization. Why don't we just put these things together? So if you have any, this is an interactive piece. If you have any answers to this, drop them in the chat or just say them out loud.
Maybe we want to, maybe we want each application we're using to only serve one specific purpose, and sort of storing the data and manipulating the data are different purposes, and we want to separate them in order for us, so that it was easier for us to change them later.
Let me see. Why not doing the same thing?
Yeah, exactly. So I think that's kind of the I think there's two big components to this. One is what Ilya mentions, is that manipulating data and storing data are kind of different problems, and you don't want to entangle the two because it gets a little bit complicated if you have these components that are doing pretty different things and they're all intermingled together. So instead of having to change code in just like one aspect, now you need to touch this application that has code for both, and it's very easy for the code to get entangled, right? And so it lowers the complexity in your development process. And as part of lowering that complexity, what you also will very often see is that the efficiency of the applications individually go up really, really quickly. So this is a phenomenon that we're not going to get into in here, but it's important to kind of understand that when you have components that are responsible for single tasks, their efficiency and performance are much higher than when you have components responsible for multiple tasks. And this is true in general, and I think it's kind of clear to see why this is the case. And this is one of these things that I'm okay saying, like, I believe that this is globally true. The other thing I would also mention really quickly is that by separating applications that are responsible for modifying data and applications that are responsible for modifying and manipulating data, and applications that are responsible for storing data, you get this other significant advantage, which is that you can independently modify both things. So for example, if you have a website like the New York Times, imagine every time you wrote an article, you had to restart the entire New York Times website. This would be kind of intractable, right? Like, you would need a whole team responsible just for restarting the website every single time one of your authors publishes some article. And I hope it's clear to see that this would be catastrophic very, very quickly. But by separating these two things, now you can have someone working on the website and they don't have to know at all what your article release schedule is like, or if someone's writing an article right now or anything like this. Just when someone publishes a new article, it doesn't matter for you as a website writer, because these two things are disjoint. Okay, so I mean, we can do this demo really quick. So all I want to show here is that what I'm saying is not just nonsense that I'm making up. It is indeed the case that we are loading a bunch of data when we load some websites. So here we can see, there's this nice network tab on Chrome. Actually, most browsers, but for some reason, Chrome's is quite nice. Even, well, I shouldn't say anything like this. But okay, so let's just start recording. So here I'm refreshing it. And so you can see indeed that, I'm not just kind of making up this information. It is indeed the case that when we make this request, we hit some server, and the server says, okay, here's all that you need to actually be able to visualize and understand the content of our website. So there's all sorts of kind of stuff here. So one is like the HTML for the web page, which you can see here. There's like different pictures. I don't know why it says no response data available. That's kind of strange, but different pictures on the website, and other various things, right? So here's like US counties.json. So this is some data that's being loaded, probably corresponding to this COVID dashboard that they have, and all sorts of different kind of stuff, right? So it's clear that indeed, we did go out and say, what does the New York Times look like? And we're getting a bunch of information that tells us what constitutes the website across our network. Okay, so we kind of went quickly through this, but this is kind of just to open up some sense of what this problem space is and how indeed you do get data across the web. Are there any questions or comments at this point? Okay, so now we can move on, and the next thing I want to talk about, and this is going to be like the majority of what we talked about today, is this thing called HTTP. So I think a natural question that can arise, like when we see stuff like this being transferred, to our browser just because we typed in NewYorkTimes.com, is like, well, okay. What is actually the process that happens when I type in NewYorkTimes.com and it like just sends me back a bunch of data? Like, how do we know like how to interpret all these things as? And furthermore, like, if I go and click on some link, what is the process of communication that happens between myself and a server to be like, okay, like, you want to go here, here's what you should do in order to to move between this web page and the next. And so like you can kind of talk about this on many different levels, but today I just want to talk about it on a level that's a little bit more beneath the surface than what we see immediately when we just load a web page. So this has to do with HTTP, which is an application layer for transmitting data, and TCP, which is a data transport layer underneath that. So if you don't know what these things are already, what I just said doesn't make any sense probably, and you're like, well, what, that's all great, but what does it mean? And we'll get to that in exactly a second. So as I was saying, when we do load a website and we have some data that's being sent to us, like, something really is happening. It's not just magic that we're getting, stuff tossed over the network. And indeed, this thing that we call a network, where we have data being transferred from one point to another, is actually like a very complicated system that's managed by a variety of software and hardware. And the important thing for us is that the browser is doing a lot of this work to get data given, that a server says, okay, this is what you need. In order to get it to our machine, some work really needs to be done. So HTTP is this thing called the Hypertext Transfer Protocol, which is a way to say, okay, here's some information that you need, and I'm going to send it across the network, and Like this is what it should look like when it gets to you. So on a very loose sense, you can say like, okay, HTTP is this thing that's responsible for this transmission, or kind of describes this transmission. But I think like kind of a non-obvious thing also is like, well, what do any of these things mean? So hypertext, you can kind of say, you know, it's just, I think this is kind of a terrible term, but let's just say it's data for our purposes. We have some data and we want to transfer it, right? I think these two things kind of make sense if you think about it this way. So you have some data, you want to transfer it. Now the question is, well, what do you mean by a protocol? Does anyone have any suggestions here?
Is it like a set of rules that you have to follow, or?
Yeah, great. That's exactly it. So when we say protocol, we're just saying kind of what I mentioned a little bit earlier, like how should the data be sent across the network? How should I interpret it? How should I interpret it? When it goes from one place to another, right? Because at the end of the day, like it's just binary, right? And again, why does it have to only be binary? It might not be clear at the level that we're talking about, but okay, just let's wave our hands a little bit because we have to do this a lot. Let's wave our hands and say, okay, at the end of the day, like it's just bits being streamed across some physical wire. And it's not obvious that, if I send you a bunch of bits that say 1101, et cetera, that you should see it in any way that I intended for it to be sent out, right? So, the classic example is like you send someone 8 bytes. So on a 64-bit machine, let's say this is 64 bits, and then so I send you this, and you get it on your side, and then it's kind of unclear to you without any previous information. How should I actually treat this? Should I treat this as like one segment of 8 bytes? That's like an 8-byte integer. Should I treat it as 2 4-byte integers? Right? There's all sorts of kind of stuff that can be very non-obvious if you don't agree beforehand. Okay, this is what I'm going to send to you. This is how you're going to treat it as. And so HTTP encodes one standardized way for the web to treat different data that's being sent across the network. And the principal idea in HTTP is like you have these things called requests and you have these things called responses. Okay, so I think from the name, it's kind of it's almost immediate to have an idea of what's going on. If I'm somewhere on the web, let's say I'm just on my computer, and I want something from someone else, like the New York Times, I'll send them a request, which is encoded in a particular way. The New York Times gets my data that I sent to them. They say, okay, well, this looks like an HTTP request. Let me process it. I know how to process it because I know what the HTTP protocol says I should process it as. And then it generates, some data that corresponds to what I wanted to know from this request, and it sends it back to me as something known as an HTTP response. And then I get some data from the New York Times. I say, oh, well, this is an HTTP response because I know that the messages that I get are either requests or responses, and this one looks like a response. So I'm going to treat it as the response to what I previously asked the New York Times. Okay, so again, we're kind of waving our hands and talking a little bit more humanized than what it really is. So I think maybe it's good to kind of look at these requests and responses. So let's do this in an immediate way on the New York Times. So we already have all this stuff telling us what we loaded up. And actually, I realize now that we won't actually be able to see what actually we will be able to. Okay. I'm just talking to myself now, but let's load up something interesting.
I have a quick question. So
Yeah.
You talked about that like HTTP is a protocol, is basically a convention for transmitting data from one place to another. But what sort of rules are included in that convention, other than like the fact that how to interpret data in terms of bits, for example? You said like 4 bits, 2 times 4 bits, or versus like 8 bits. Other than that, what other rules are included in the protocol?
That's a good question. So the main one is this encoding. The other one that I'm well aware of is how data, or how this data can be transmitted across the network. And what I mean by this is, we'll actually get to this in a couple of slides, but in the first instances of HTTP, HTTP would say, okay, you make one request, like let's say I'm on my computer and I make a request to some site. So I make a request to the site, and then before I can make a second request to the site, the HTTP as a protocol will ensure that the request gets to the site or times out, which is like something we won't talk about right now. But let's say these networks always are reliable and the request always gets to the site, and then the site sends me a response back. So this kind of balancing has to happen before I can make any other request. And this is like a rule imposed by the protocol to say, okay, anytime you make a request, I'm going to guarantee that you get the response back in the same order that you made the request. And so you kind of have this sort of consistency that's enforced by the protocol. If you send off one thing, you know that the next thing that you're going to get back corresponds to the thing that you just sent off. So that's like one other very major thing of this protocol, is just ensuring how data is transferred and the kinds of guarantees that you get about when you're going to get a response back, or in what order you're going to get a response back from someone when you ask them something. Does that answer your question?
Yeah, it does. Thank you. And also
Okay.
another quick question: where does
Yeah.
this protocol, like, where are the rules enforced? Are they enforced like on each node of the network, for example, or like only in the browser? Where do we make sure that the request that we're sending follows the, I guess, the protocol?
Yeah. So it just exists on any node in this network that you want to talk in HTTP to. So this is kind of a little bit of kind of an opaque concept to understand, I think. But the idea is like, you know, let's say you and I want to communicate in some way. So right now you and I are speaking English. The thing is that both of us have to know how to speak English on both sides and how to understand English before we can have any meaningful kind of conversation. And so in a similar way, if you have, but like, for example, you know, you and I could also be speaking some other language. You know, we could be speaking Mandarin, or you know, any other of the thousands of languages that are out there. So similarly, if you have two nodes on a network and you want them to talk to each other, you need to know ahead of time the way that they can communicate. So one way that they can communicate is via this HTTP thing that we were talking about right now, and there are plenty of others that you can find online. So yeah, does that answer that?
Yeah, it makes sense. So it's sort of like a set of rules that each of the node knows, and when the request or response comes to them, they know how to interpret it.
Exactly. Yeah.
Okay. And like, are there any other protocols? And if there are, how does each specific node like differentiate between the nodes? Not the nodes, between messages sent in different protocols. How do they know how to interpret the message, which protocol to use?
Yeah, so that's also a really good question. There are, so let me just pull up a picture, because I think this may be. I always forget what this thing is called. Okay, so the idea is that, okay. Okay, so the note that I meant earlier, that applications are kind of these that networks are kind of these very complex things that have lots of hardware and software devoted to them. I meant this like very legitimately. So, the modern networks that we use today, there are like 7 layers of things that happen in order for let's say me sitting on my computer to get some information from some other server somewhere else. So there's some data that's packaged up in an application in a server, and it goes through like these 7 layers to send the physical bits across the wire to me, and then I similarly go through 7 layers in order to figure out what it should look like on my. There's something in the chat. Yeah, I know. I was about to plug in my computer. Thank you for that. But yeah, so I also go through these 7 layers to figure out what what am I trying to say? What these physical bits that you sent me should look like in my application, namely the browser, for example, right? So the level that we're talking about right now is this part right here, the application layer. HTTP is an application layer protocol for networks, which just means that like it's a way to encode and decode data on the level that we can do so in something like a web browser or a web server. But there are many different other parts of this. So probably the part that you're talking about is this presentation part, which says, okay, what does this, what is the data that I'm looking at? What application layer protocol does it belong to? And what application layer protocol should I invoke in order to decode this data that's been sent? So similarly, like, if you and I are speaking Mandarin, it would be it would be pretty easy for us to tell whether we were speaking English or we were speaking Mandarin. But if you kind of squint a little bit and you think about it, well, the reason that we know that is because we had a little bit extra information that, for example, maybe I was saying some syllables that don't exist as syllables in English, and the only other thing that I could deduce is that we intended to speak Mandarin. So there's kind of this like inference level going on as well to figure out, are you speaking HTTP or are you speaking something else? And should I route this data that you sent me to be decoded by HTTP, or should I route it to be decoded by some other protocol that I have? And there are other protocols. You can kind of look this up. You can just search up application level network protocols, and I'm sure you will find many.
That makes sense.
Okay, so
thank you for explaining.
Right. Okay. Let me just plug in my computer real quick. Well, I hope it starts charging. Okay. All right, so we're running a little bit low on time, but this is okay. I hope that this has been helpful to someone. So just really quickly, let me show you some requests that may have been made. Where did this go? Oh, that's not what I want. Okay. All right, so here's a request that I made to the New York Times server to get the HTML for this page, right? And so this is kind of like a pretty printed format of what the actual data in that request that I sent off to the New York Times looks like. So I said, okay, like, here's a resource that I'm requesting. And by a resource on the web, we generally just mean a URL. So that's kind of like the canonical way for talking about something that we want some information about. So I'm saying, okay, I want to know what the New York Times looks like. I I'm asking you to do this via something called a GET request. These are all these REST verbs, or sorry, not REST verbs. All these HTTP verbs like GET, POST, SET, etc. that we don't have time to talk about. But you can look up what this is if you want to and already know. Yeah, so there's like some other stuff here. So like this is some referral policy. I actually don't know what this is, but we're just encoding some information and saying like, here's the information that I want. And then the New York Times sends us back a bunch of other information. So an HTTP response, request and response consists of two things. There's this thing called a header, which contains a bunch of meta information, and a body, which contains like the actual relevant information you want to send across. For a GET request, there is no body because you're saying, okay, like I just want this resource, which is like a URL, and that I can just put in a header somewhere. For a response, it's a little bit more complicated, right? Because if I'm saying, what does the HTML for this web page look like? I do want to send across the HTML as well. So here we have listed the headers of the HTTP of the response that the New York Times server gave us, and in this response tab, Chrome is very nice to kind of show us what the whole HTML looks like. And this is exactly the HTML that is being displayed right here on the right? But okay, like you can also go through these response headers and see, okay, it's telling you how big the HTML that's being sent is, and all this other kind of stuff. So I hope this gives you a sense for what these things really look like. So it is really encoding some information into some format, sending it across. The other person decodes it in some format, says, okay, this is what you want. I know how to get it. They get that data, package it up into some nice format, and send it across the wire again. And you say, okay, well, I know how to decode it in some way here. Okay, so let's kind of rush a little bit. So the thing that so okay, let me ask you all this. Are you aware of the differences between HTTP 1.1 and HTTP 2? And if you don't, or if you do you care and do you want to go over this? Because we have like 10 minutes, we can either like go over this and maybe it'll be interesting, but maybe not, and we can get to everything else that's in here. Well, it depends on what you mean by doesn't matter. So like you have to think about this like a little bit if you're thinking about how to send information from a server to a client or vice versa, and how you want to make requests. But if this is not something you care about, then maybe it doesn't matter either. But yeah, like if you don't mind going over an hour, we can sit here and talk through this, because I mean it's not like it's going to take 30 minutes or anything like this. But if this is not something people are aware of and they want to know, and they don't want to know this, we can move on. But let's kind of get a yes or no from at least one person. All right, so we're going to go over an hour, and if you have to leave, no worries at all. Just make sure you fill out the feedback form. Okay, so all right, so so I mentioned this a little bit earlier in response to Ilya's question, which was Ilya's question was like, what else does HTTP guarantee you other than just what these messages look like? So in HTTP 1, one thing that you were also guaranteed is, I'm talking like, let's say I'm talking just a website. I make some request, they give me a response. I make some request, they give me a response, right? And it's kind of like this one-to-one transaction, and it happens in increasing order. So the next one can't happen before the first one does. So this is kind of the interaction that we're seeing right here. I'm saying hi, the server comes back and says also hi. I say, okay, like, what does a house look like? It says, here's what a house looks like, and this conversation kind of keeps on going. Now, if you think about this, there's kind of a little bit of effort being wasted, because every time I make a request to someone, and this is not something that we're going to talk about here, but again, let's wave our hands a little bit. Every time I make a request to someone, I have to go through a lot of work of like packaging up this request and actually opening up this thing called a connection, which is like the channel responsible for actually sending the data across the network, right? So remember, our HTTP protocol is just responsible for like packaging up some information that we want to send it in a nice format, in a nice binary format that we can send across the wire, or unpacking it into a nice format that we can read, in our software or even as humans, right? That's all that HTTP is doing. It's like a way to encode and decode this data, but the data also needs to be sent across the network for real. And so if every time you open something up, you have to like sit there and wait and get something back, and then you close this channel where you've been talking on, there's a lot of wasted effort if you have to do this many times. The question is, can you reuse this channel multiple times to send multiple messages? And the answer, unsurprisingly, was yes. So HTTP 1 came out in like the mid to late 1990s, I would say, I think. And then HTTP 1.1 came around. I actually don't know when, but it came around sometime later, and it was trying to solve this problem of like, okay, our web pages are now kind of getting lots and lots of data across the wire. And every time we have to open up the new channel for every single request, we're wasting a lot of resources, because this isn't like the cheapest thing in the world to do. So instead of having the single channel where only one request could be sent, HTTP 1.1 said, okay, we'll let you reuse the channels. So if you want to make several requests in a row, you can use the same channel. And this way you're avoiding the cost of creating and destroying these channels that you're sending data across every time you want to make and receive an HTTP connection. So in this example on the right, we're saying, we start off a conversation with a server with a request that says hello. They say hello back, and then we say, okay, wait, we're not done yet. Can you also send me like a picture of a house, because that's what I care about? And the server sends us back. We say, okay, wait, we're not done yet either. Can you also send me a picture of a car? And the server sends the car back, right? So we kind of like widened what we're able to send across the wire for one thing. Does this make sense? Okay. So this happened, but the problem was that you still had this problem where even though HTTP 1.1 let you send things kind of across, when you send multiple requests across one channel, the problem was still that you had to wait for one request to come back before you got the next one, So literally what the server would do is, like, let's say I sent this message. I have to send this message first. Then the server has to receive this message first and send the response back. Then, even though it's on the same channel, it has to get this second message next and send that second message back. Then get the third channel next, or get the third request next and the third message back. So even though we've widened this channel and let you send multiple messages across, you still have this problem where you have to kind of process them in order. Does this make sense? Okay, so this is also a problem, right? Because let's say I have some really, really expensive requests at the beginning. Let's say I'm playing some game or something, and the first request is like load up all the friends that are online currently, and the next two are like load 2 images or something, right? The first one is going to be super, super expensive, but the other two are going to be blocked on this first one because HTTP 1 says this has to be processed first, right? So we could have swapped the order, and these two would have been really, really fast. And then we would have just been waiting for this thing. But now we're waiting for all three of them because this guy at the front is the slowest of the bunch. So then, like in 2015, I think maybe you heard about this or maybe not. I didn't hear about it, but like some of my friends are like, "Oh yeah, I can't wait when HTTP 2 came out." I'm like, 2015, I did not care about this stuff, so I don't know why you did, but okay. But so HTTP 2 came along, and they were like, all right, like this kind of stuff is nonsense where you have to like wait for everybody. So concurrency and parallelism is like kind of becoming a big thing. Browsers are getting more and more complicated. Web pages are like loading thousands and thousands of requests like during a single session that you're on a website. And they say, all right, like this stuff where you're blocking requests just because you have like one expensive thing is like a terrible way to do anything. Let's just parallelize everything. So HTTP 2 says, okay, now you don't have this nonsense where you have to wait for everybody. Indeed, you can have parallel requests at a time. You don't have to wait for one to get back before the other. It truly is parallel, okay? And actually, I'm lying a little bit. It's not totally parallel, but for our purposes, we just say they're parallel requests. You don't have to do them in order. They can be sent whenever they want, right? So we're happy, right? This is it. Like we got this problem solved. We're not blocked on a single really expensive connection. Does this make sense?
Are the responses still coming like in the same order that we send the requests?
No, they don't have to.
Mm-hmm. So there's sort of parallel, right? Like, yeah.
Yeah, so by parallel, I just mean that I'm not being blocked on any other connection inherently. So
yeah, that makes sense. So like one request doesn't block any other. Like if the server is ready to send data back, they'll be sending, that server will send the data back without waiting for other requests to finish, right?
Yep. Okay, so like, go ahead.
Sorry. I also had another question, like, why is initial handshake, like saying hello and then saying goodbye? Why is it necessary? Why not just send like the data right away and wait for the response? And if the response doesn't come, we'll just assume that like the server is not responsive or not working.
Oh, yeah, the initial, like, this is just some visualization that I found online. So this is not really representative of what the actual communication is like. You don't have to do this hello and goodbye stuff. You can kind of just jump immediately to the stuff in the middle. Yeah, that would have been good to point out. Thanks for mentioning that. Yeah. Yeah, okay. All right, so problem solved. This really nice thing. We're not being blocked by anything anymore. But you know, life isn't great, and there are numbers above 2, and everyone wants to make an HTTP 3, right? So some people sit down and they're like, well, things are still kind of slow. Things aren't super parallel all the time. Like, what's going on? So you know, I'm kind of giving this away, and maybe it's already obvious because this is kind of like the central point of everything we've been talking about, and then we're going to get into a lot more detail next week. But maybe everything isn't as great as it might seem from this HTTP 2 thing. So the question we have, I have for you now, and you know, if you don't know, this is totally okay. But last time we talked about this idea of leaky abstractions, and that JavaScript, for example, or browsers are leaky abstraction. It's not like you can just write any JavaScript and it's going to all run equally. You have to kind of think about how the browser processes your JavaScript in order to understand what JavaScript you should write, even though these are kind of two separate things. So the question now is is this HTTP protocol where we say, okay, I compact some data, I transfer it over the wire, and in HTTP2, I can send it parallel. Is this a leaky abstraction? And if it is a leaky abstraction, which means, you have to think about things that are below HTTP2. But you have to think about things that are below HTTP, not just HTTP itself. What is a leaking? And if not, why is it not a leaky abstraction? So if anyone has any comments on this, please say something. And if you just want to guess, feel free to guess.
By leaky, do you mean the interpretation of HTTP depends on the underlying stuff? Something bad might happen when let's say browser interprets HTTP?
Yeah, but I would say maybe think a little bit more regarding the behavior of HTTP. The representation is also a factor. But I'm kind of trying to lead this towards a discussion of its behavior. Okay, yeah. So the discussion is obviously came out of the middle of nowhere. So I don't expect anyone to have a good answer for this. So the answer is that yes. This HTTP2 stuff where we saw everything's parallel, nice and great, actually isn't the case, because there's this thing that sits below HTTP called TCP, which is this whoa. Yeah, it should be data. I think maybe I'm being an idiot, but oh, okay, no, it's transport. Yeah. So there's a thing called HTTP, which is responsible for transporting the bits across the wire. It's kind of like the lowest level where you don't have to care about hardware yet. Okay, so you can think about it we'll talk about it a little bit more. We'll talk about it a little bit more in a second. Basically, it's this layer where you're actually sending. It's responsible for actually sending the bits across the wire. Okay, so you package things up in HTTP. You lower it down a couple of levels, and you get to this place called TCP, and TCP is actually going to send it for you, or be responsible for sending it for you and making sure that it gets to the other side in a consistent manner. Okay, so if you think about it, okay, it's obvious that anything that HTTP does up here relies very, very heavily on this TCP thing, and indeed, we will see in a second that this parallel kind of business that we were promising HTTP2 is actually very, very heavily reliant on the behavior of TCP at this layer. Okay, so maybe this is still very foggy and very vague, and that's okay. We'll try to walk through this. Okay, so as I just mentioned, HTTP is this application layer protocol. So you get some data, you encode it or you decode it, and that's the information that you want in your web browser or web server, for example. Alternatively, you have a web server, you package up some data in the format specified by HTTP, and it gets lowered down the stack until eventually you send it across the wire. So TCP, as I just mentioned, is this part right here that's responsible for actually segmenting the bytes or the bits that you're going to transfer across the network, and making sure that it gets from one spot to the other reliably. Okay, so you can kind of just think about it let's think of a good example. Maybe you're running a courier service, and your courier service delivers gifts So you have two things going on. You have a gift wrapper that wraps up a gift, gives it to the courier. The courier is actually going to be responsible for making sure it gets to the car, gets in, make sure it gets into the car, that the car gets to the other side, and that the gift gets taken out of the car when it gets there. And then once the gift gets there, you have someone that unwraps the gift for you. Okay, so the gift wrapper and unwrapper is HTTP, and this person that puts the gift in a car is this TCP part, right? Okay, so the leaky abstraction that we're going to talk about now is this thing called head of line blocking that TCP does. So let's recap really quickly again what this HTTP stuff did. So in HTTP 1, we said you have one request at a time, right? You have to send one request, you have to wait for it to get back. And you send the next one, they wait for it to get back. HTTP 1.1 said, okay, this is kind of garbage. Let's let you send multiple requests at a time, but due to limitations that we had at the time and a myriad of other factors that I'm not really interested in getting into, you still have to have this ordering this ordering requirement. So the first request that you send, it has to be the first one back. Second one you send, it has to be the second one back, etc. Right? The problem here is the first guy that you send blocks everybody else. HTTP 2 said, okay, whatever, like, again, this is nonsense. Let's make everything great. Let's make everything parallel. Okay, this is where we left off a few slides ago. Kind of, probably annoying you with this point, but I hope you're internalizing it. Okay, so the problem now is that, remember, we still have this courier guy that even once we package up, our information into a nice little box and say, okay, can you go and send it off? The courier is still going to do something, okay? And this is the part where it gets like, oh my God, why do I have to think about this? So the thing with TCP is it's a very diligent courier. It makes sure that when you send some information off, it gets to the other side with some degree of attempts to make sure that it gets there. So TCP has this objective where if you send some information, it's gonna guarantee that it gets to the other party. And if it doesn't get there, it's gonna resend this data until it gives up and says, okay, well, this thing I just can't send it to it, or it does indeed get there. So it's like a very reliable courier in this sense. Now, what TCP also does is it says, okay, let's say I have a bunch of requests that that I've been given. So I'm TCP. I've been given a bunch of requests that I want to send over network. Right now, even though I might send them in parallel, what happens is if one of these packets gets dropped. So if I try sending it across the network and the packet just doesn't get there, this can happen for a number of reasons. Because even though earlier we said that we can kind of, let's pretend for now that networks are these kinds of very perfect things where I send something off and I get something back. In reality, they are very, very unreliable. They're very, very easy to break down. So, that's the whole reason TCP was invented. So if I send something off, TCP is going to retry it if it knows it didn't get to the other side. So if I have a bunch of packets being streamed in parallel to some target, and one of those packets doesn't get there, then TCP says, oh, hold up. This packet just got dropped. So I'm not sure if the person on the other side is actually there. So what I'm going to do is I'm going to make all of you wait, and I'm going to retry this packet until it gets there. Then once it gets there, then I'm going to let everyone keep moving again, right? So if you think about this, you're like, oh, this is kind of this kind of breaks down this whole idea of parallelism that HTTP 2 said that we had, right? Because if a single request doesn't get there, everyone has to wait until it gets there, and then it's like, okay, now you can keep moving again, right? Does this make sense? Did I go too fast?
So TCP connection doesn't have like it's just one connection, and it passes one thing at a time, and it doesn't. And if TCP like can't get it to the other end, it's not sending the other packets until it gets that one to the receiver. It's not possible to send several packets at the same time through a TCP connection, right?
Well, I mean, actually, that is what's going on here. So so think about like these red boxes, for example, as being like one request that you're sending across. This blue stuff is another request that you're sending across. This green thing is another request that you're sending across, right? Because at the end of the day, it's just bits. So like it packages them up into bits and like sends those bits across these things called streams. Okay, so there's one TCP connection and 3 streams. So we're sending 3 requests across a single TCP connection. And in fact, they all are going in parallel. But if a single one from a, if a single packet, which is like, the sequence of bits for our request, gets dropped while we're sending any of them, TCP says all of you need to wait. All of you need to wait before I figure out what's going on with this guy. And once I do, then you can keep going again. So they are being sent in parallel until this guy gets dropped. And then it says, okay, now everyone needs to hold up and we got to figure out what's going on. So at this point, this is when the parallelism breaks down. Because like we don't know why this packet got dropped. It might or might not affect this red or green request that's being sent across. But TCP is very conservative and it says, okay, let's just make everyone wait. But HTTP 2 said, like, everyone can go at the same time. So TCP, even though HTTP 2 makes this promise, TCP says, no, that's not the case. It's not. I'm not going to guarantee that that's always going to happen. Did that answer the question?
It did, yeah. Thank you.
Okay, so this is again, this is like one of these kind of non-obvious things that like I didn't know about this until like a few weeks ago, and I was like, I can't believe this is the case. Like, come on. I've been like doing so many things thinking like it behaves one way, and then you kind of look a little bit closer and you realize nothing is how it appears, right? So this is like another big problem that really is the case. Like, when we think about ourselves as like developers or engineers or whatever, like there's a lot more going on at every level than we might expect. And the problem is like you still need to know like so much information just to even understand what the problem here is. I think if I was in your position, I would probably still be like, wow, this is very vague, and like I don't really fully understand what's going on. I can't internalize it well. And in fact, I feel the same way. Like, I don't know everything about this kind of stuff. But there's kind of this balance of like, I need to know enough to get my job done, and I also need to sleep, right? So you kind of have to find a middle in between somewhere. And then you realize this kind of thing, you're like, wow, like maybe I need to sleep a bit less and know something for my job a bit more, right? And so there's this kind of trade-off that you have, but in the end, you realize that anything that you build is going to be very, very complex and rely on a lot more things than you might think about immediately. So I hope this gives you another sense of that. And in a couple of weeks, when we talk about the 3rd and 4th lecture, we're going to go into a lot more detail of these kinds of examples. Okay, so I hope I didn't confuse anyone too much. I hope at least you can wave your hands and be like, okay, like HTTP 2 promised to be parallel, TCP said no, you're not actually parallel, and our lives are ruined. So the last point I want to make here is like some people were like, wow, this is terrible too, because I want to be parallel and I'm not. And also I like numbers that are above 2, and I want to make another major version. So some people are like, wow, let's make HTTP 3 where we do really have parallel stuff. And so there's a thing called HTTP 3 and the QUIC protocol that's being worked on today with like some guys from Google and some people from Switzerland. And they have all these like crazy new ideas about how to do this stuff. So if you're interested in that, you can kind of you can go out and learn more about it. But yeah, so that's the last comment I'll make about this. Okay, so any questions or comments about this section? Again, if you're confused, let me know. If you don't care, also let me know. Yeah.
So we have this problem, right? Like that the fact that TCP doesn't allow for sending requests in parallel. Does it create any direct implications for us as developers? Like, for example, in case of JavaScript, the topics that we discussed last time, we understood that we have to know how JS is interpreted in browser inside the engines, let's say, and that led us to the fact that we need to write efficient code. We have to understand how it works. Are there any implications directly to us from this example, from this problem?
Yeah. I mean, I think there are a few, and actually, I think this is like kind of the next thing that we want to talk about. Okay, let's skip over databases because this is, I literally just have one slide about this. So if you're interested in databases, go out and learn about them. Just know that basically they're just giant sink to hold a bunch of data and are highly efficient for storing data and retrieving it and finding relationships between them. Okay, so we don't have time to get into this. Go learn about it more if you really care. And if you really care, go do a data engineering internship, because I hear that those are great things to learn more about this kind of stuff. But today we're not going to talk about it. And so now to get to Ilya's point, or to Ilya's question is, how does this affect us as developers? This stuff about HTTP that we just talked about. So let me first open it up as a question to all of you. And then if it's not covered in the discussion, I'll also mention a response to your question, Ilya. So the first thing that I want to ask the three people that are in here is, let's say you're making a website. What do you think would be a better thing to do? To load a bunch of really big things all at once, so like big JavaScript files, big HTML files, big CSS files, all at once, or load a lot of small things over time. So maybe you break up your JavaScript and you load like incremental parts of it over a very long period of time on the website. What would you think of first, and why? The why is kind of key here too. Okay, why?
Because I think if you send like a stream of a lot of big things, the chances of failure, like something like, I don't know, like a packet loss is much higher and it can ruin the whole thing. So if you instead send like a bunch of smaller things, even if one fails, I think it's easier to maybe retrieve or restore if that's the case.
Okay.
Maybe, I don't know. If you're sending like, I don't know, like a JPEG over a browser, then maybe that's not the case. So.
Okay, and so someone else in the chat mentions additionally, and the ones that get there quickest can be loaded without waiting for the others. Okay. Are there any other comments here? Okay, so I would say I think the conventional wisdom today is exactly what you all are saying, but I will also add that this is a very like a very sensitive question, and it depends a lot on the context that you're operating in, right? So first of all, just like as a really quick aside to what Ilya originally asked, is like, why does this HTTP stuff matter? So it matters because what kinds of things you do here make a difference depending on what kind of HTTP protocol that your web speaks. So back in the day, like what am I trying to say? So you know, today everyone pretty much speaks HTTP2, and so like you know, you can kind of be guaranteed that the things are going to behave one way, minus this TCP blocking parallel stuff that we talked about. But let's say you're in HTTP1 world, you know, then you have this thing where you have to send like one thing, wait for the next, you know, wait for the next, etc. So there, like, it might make a little bit more sense to load a lot of small things at the same time, right? Because, you know, then you have this guarantee that you know, you get one thing back, you can kind of process it at the same time. You have this next request that goes on. So you're not being blocked by just one thing. Now in the HTTP2 world, if you just think about the network, it actually doesn't make a whole lot of difference. And in fact, it might be better to send a few big things all at once because you have this kind of parallelization process. And also because of this problem that we noted, that TCP is not truly parallel. If you lose one packet, you might have to wait for everybody else. And in fact, you know, if you do some measurements, what you will see is that if you just send a few larger streams, those are less likely to lose packets and be dropped, and then everyone else has to wait. Then if you send a lot of smaller, but a lot more of these small responses or small streams like across the connection, right? Because remember, the bottleneck that we have with HTTP2 is even though things are traveling in parallel, if one piece of data that we're transferring gets dropped, everyone has to wait. And so statistically, it turns out that in fact, if you do have a few number of larger streams, those are less likely to drop and hold everybody else than if you're sending a lot of small things all at once. Okay, so you know, if you look at it just from the network perspective and you look at it just from like, okay, am I working with HTTP1 or am I working with HTTP2? What you're doing might differ, right? Now, what you all have said is also like a very valid point. Like, once you get some small thing, it's easier to process, right? Because you can process it immediately and then not have to wait on someone else very large to be processed or to be blocking you. And so there's this other component of like, well, you know, if I'm building a website, like, do I want to load everything all at once and then have to make my user wait before they can actually see anything on the web page, or do I just want to load like just enough for them to have some kind of reasonable experience before I have to load actually everything that's responsible for my website? So let me see if I can go to the next slide. Yes, so we're going to do an example in a second, but this is kind of these 2 points that I made are exactly what I'm trying to summarize here. Is that it matters on the context. One is like what is the protocol that you're using, and what are the criteria for the network that you need. And the second one is, you know, do I want everyone to have to wait for everything to load before the application starts to run, or do I just want to load enough so they can use it, and then later on, as I need to, I can kind of send more information through. And I think this is what you three were trying to say. Okay, so if you have any comments or questions right now, feel free to jump in. Otherwise, we're going to do a quick demo of this last note. Okay, so here's the example that I want to show, and like we're going to do this kind of quickly and a little bit lazily, since I really don't want to go. I don't want to keep you more than 30 minutes extra that I did. So we're going to do 2 things. We're going to look at what the New York Times loads, okay, and we're going to look at what Reddit loads. Now, these probably aren't the best examples in the world, but it'll do for our purposes. Okay, so let's do the New York Times first. So I'm going to refresh this page, and hopefully Chrome will record all that's loaded. and then we'll stop and take a look. All right. Okay, where do I stop this thing? All right. So here's kind of here's the relevant part that we want to look at. So the metric that I'm really interested here in here is this thing called DOM content loaded. This tells us, when has the entire like HTML for the page been loaded. You can roughly think of this as like, okay, when is the web page finally usable? So it took 3 seconds for the DOM to be loaded, and like maybe it would have been usable a little bit beforehand, but in general, we can say, okay, it took 3 minutes for the website to be like responsive for a user, right? And so we can see that like a bunch of stuff was loaded before this point hit. Okay. So now, and also, wait, okay. And also like relatively less stuff was loaded afterward, right? Do we all agree with this? Okay, I'll take that as a yes. So let's maybe Reddit change their entire performance criterion between now and yesterday, but I measured something very different on Reddit yesterday, so hopefully we'll see that that's the case today too. Okay. All right. That should be pretty good. All right. So Reddit, on the other hand, so first of all, you have to understand that Reddit has a lot more. Well, okay, actually, okay. Let me not say that actually. We'll just look up this. Supposing that Reddit and New York Times have roughly the same number of information on both of their pages, which may or may not be true, but let's just say for the sake of simplicity that it is true. Okay, so we can see that Reddit took like roughly about as long to become responsive as the New York Times did. But what's interesting is that, even though Reddit loaded a bunch of stuff and took this long to become responsive, it still kept loading a bunch of stuff afterward. And so it becomes kind of clear that Reddit is being a little bit more clever than the New York Times maybe is here, by at least on the front page, like not moving any further. It's saying, okay, like this is probably what I need, like the stuff at the beginning is probably what I need in order for you to have a usable experience right at the beginning, and I'll load that much. And even though it may take me some time to render, it's not as long as it would have if I try to load everything at once. And so, after you're in a place where the web page is maybe a little bit usable, then you say, okay, let me like incrementally load everything else. And it's clear that like we're not even looking at the whole time scale, but like roughly half of the information on this web page has been loaded after there's some sense of usability on the web page, versus like the New York Times, like maybe like a quarter, like a fifth of the information was loaded after the web page was already usable, right? And so this might give you a sense that like, okay, maybe Reddit is taking a little bit more steps in the design of their websites to be like, okay, what do I need in order for the HTML on the web page to load, and what can I save for after that's being done, right? Okay, so we can kind of skip over this question. If you're interested in this, you can kind of look at this time scale and see that, wow, networks are kind of slow, and basically everything is faster than a network, and we shouldn't, try to minimize how much time you're spending waiting for stuff to come over a network, because it's pretty slow. But I do want to ask, does anyone have any additional like comments or questions on on this thing that we just talked about.
Can you say like the key takeaway from like we just watched the demo, right? What is the main takeaway from there? I understood everything was happening there, but like what was something that I was supposed to like to retain?
Well, I really just wanted to show you that that the behavior of these two websites is very different. And I mean, it is the case that it's not really obvious as to why they're different, and maybe it doesn't really matter so much. But the point that I want to make is that if you look at the data that Reddit has loaded before the web page has been loaded and roughly is usable, it's a very small amount of data compared to what they load afterward. Okay, and so now you can kind of squint a little bit, and you can say, well, if they decide to load everything all at once, it would actually have taken us, like, I mean, what is this, like 8.5 seconds, which I'm looking at this bar right here, 8.5 seconds to load everything, and then our web page would have been usable. But somehow, you know, they kind of went through this process and decided, okay, here's what I need to load in order for my content, in order for my webpage to load. Here's what I need to get over network in order for my webpage to load. And then everything else through, you know, a number of methods, I'm gonna wait to get until the webpage is like even a little bit usable, right? On the other hand, if you look at something like the New York Times, like, you know, if you look at how long it took them to load the stuff on their website, I mean, you can't compare apples to oranges. Like, you know, even though they may have similar amount of content, maybe the Reddit application is much more intensive. So even though these two websites took a similar amount of time to load, that's not really the point I want to make. The point that I want to make is that New York Times decided to load pretty much everything that it needed on the front page before the web page was roughly usable, and then it loaded like a little bit more at the end. But the Reddit took a very, very different approach, which was load a smaller amount at the beginning and then load the vast majority after the web page is roughly usable. Does this make sense?
Yeah. So like depending on the content that we have, like the goal for us is to make the user experience as good as possible, right? And like depending on the stuff that we have on the page, we might want to choose different approaches to like getting all of the data. Either get all of the data like right away in the beginning, or like spread it out and first show possibly like for example, Reddit has a lot more data than New York Times, like all of those upvotes, all of the possibly additional information. And
sure,
we want to make the user experience better, so we load that later.
Yeah.
In order not, yeah.
I mean, like another observation that you can make is like, okay, well, if New York Times took the same approach that Reddit did, and it decided to like load this critical stuff right before the web page started to get usable, let's say like it only needed to load like the same fraction of data that the New York Times did. So like maybe, you know, maybe they could have stopped like right here or something, okay? And so like when did this thing get loaded? How do I even see this? Okay, so it started at like 1 second. And how long did it take? Okay, it took like 300 milliseconds. So let's say, you know, let's try this up a little bit and say maybe they could have, you know, maybe if they only needed as much like critical data as Reddit needed, they could have loaded everything that they need at 1.5 seconds, and then gone to a place that their web page is even like remotely usable, and then decide to load everything else, right? So it could have been the case that New York Times could have optimized this a little bit and been like, okay, well, maybe we can shave off 1.5 seconds of our load time if we kind of rearrange the order that we're loading these things. And so there's two things that you can kind of take away from this. You can either take away the fact that, okay, maybe New York Times needs to optimize a little bit more and get to a point where they're only loading what they need for the website to be minimally usable, or you can make the observation of, okay, maybe New York Times has done this diligently and on purpose in order to make sure that their website is almost completely loaded before it's usable. So maybe New York Times is like, okay, well, people are going to scroll down all the way to the bottom as soon as they load our website. We want to make sure that's loaded before they do it, so that they're actually looking something viable by the time they can start interacting. So again, like this is kind of up to interpretation, and I really want it to be that way, for you to kind of see the difference that these two sites have taken, and maybe make your own judgments as to whether this is a good thing, a bad thing, and like what are the trade-offs between these two approaches. And again, it can be kind of vague, and you can say like, well, does it even make a difference? But I think that it does. I think it's a very big thing to notice that much more information is being loaded before the web page is usable than after on this site versus this site. And there are conclusions that you can make about either their intention or the practices of their engineering staff. Okay, are there any other questions or comments? We should really wrap this up. Okay, so yeah, so please leave some feedback. Today we only have 4 participants. So perhaps you can give me some of the best feedback that we can have, because I think we went into a little bit more detail in this session than we would have in others, given that you all were willing to stay over and kind of had some more pointed questions. So this is very good, and I would appreciate any feedback that you have. Again, if things were too vague or confusing, please let me know, because I realize that I can make it that way very, very, very easily. So in a couple of weeks, we're going to kind of get to what I think is the most interesting stuff relating to this. So we're not going to talk about this kind of background anymore. We're going to say, all right, now we're really going to concretely sit down with some application and figure out how to scale it up and scale it out, and what scaling stuff even means. And maybe we'll even talk about some organizational aspects of scaling. Yeah, so thank you for dropping the feedback link in the chat, Ilya. But yeah, so next time I hope to have a lot more of these kinds of question and discussion things, because I think that's where any of this stuff really matters. It's like when we think about real problems that are happening and how to deal with them. So if you're not already excited to kind of be involved in some discussion, please get ready to, if that's your thing. If it's not your thing, you just want to listen, like, that's cool too. But I really enjoy it when people are involved in these kind of conversations. Okay, so if anyone has any other questions or comments, please ask them or say them now.
I started to flood you with questions. I have a lot.
No, that's totally fine.
Yeah, I have one last one. So
yeah, sure.
Yeah, and thank you, Matt, for joining. Yeah. What was the question? How does Reddit and how does New York Times, how do they basically, if you want to load the resource a little bit later, not in the beginning, but a little bit later, are they doing this using basically scripting when they're going to retrieve their data? So, for example, some JS might load and you're getting the GS, and then you run the GS, and that script basically gets all the data that you need, additional data that you need. Does my question make sense? I'm not really sure.
Yeah, no, I mean that's like a very good question. That is a very, very strong question. I mean yes, that is pretty much effectively what is happening. I'm actually being a little bit misleading with this DOM content loaded thing. This maybe not the best metric of when we would think that a website is usable. But it's kind of the easiest for us to kind of just go through a demo in 5 to 10 minutes. So the thing is that when you write a website, you don't actually really have that much control of when the browser decides to render your web page, or let's just say to render your web page, right? So at any point in this timeline, the browser can say, okay, I'm going to render your web page, and I'm going to allow someone to start interacting with it. So like moving between the different parts, the different parts of the website. The thing is, however, that in general, the browser needs a lot of information before it can do this rendering, right? So it needs to have loaded your JavaScript, it needs to have loaded your CSS in order to figure out how it should lay the website out and to render it. So in that sense, you do have a little bit of control. You can say, okay, load the JavaScript first, load the CSS at this point, and once the browser has all these things, then it'll go out and try to render the web page, right? Now, exactly to your point, like one very simple idea that you can do is you can say, okay, let's say I have some web page with a lot of content. Okay, instead of sending like a giant HTML file with all that content all at once, what I can do is send a very, very small one that just includes the JavaScript and CSS that needs to be loaded in order, for everything that I want to display to look nice. The JavaScript, or sorry, the browser will be able to very, very quickly render like a very small amount of HTML, JavaScript and CSS that corresponds to this tiny shell that you've loaded, that you've loaded as part of this website. Then you can say, okay, now start running this JavaScript, and I'm going to populate incrementally all the information that I want on my web page. So, for example, let's say that New York Times took this approach where instead of loading all these articles at once as part of their HTML that they sent across, they just send some HTML that literally just includes like the banner here, for example, and some JavaScript at the bottom that's going to, first add on this section, then it adds on this section, then it adds on this section, etc. And this is, I think this is exactly the approach that you were suggesting, minus maybe the order of loading stuff. But yeah, you could incrementally load things this way, and so there's this thing called I actually forgot the name, but the basic idea is like, in general, you want to send just enough HTML. Let's say you have a very dynamic website. You want to send just enough HTML in order for everything above the fold, which is everything that's visible before you start scrolling on the web page, to be rendered immediately. And then everything below the fold, which is when you start scrolling, you can kind of render that incrementally, right? Because by the time someone starts scrolling, they probably already interacted with everything up here. Okay, so this, again, this is kind of a long-winded answer, but I hope that answered it.